Hi, can you see that? Can you hear me?
Hi, Joshua. Yes, we can see this and hear you very well. Just a quick introduction. Joshua has been a software developer at Garmin for 15 years, and he's an active contributor in the Yocto project for many, many years. Thank you very much for having this talk. The mic is yours.
All right. Um, Hang on, for some reason, I cannot interact with my desktop. Does this work? All right, we'll just do it that way. Okay. All right. Hello. And today I'm going to talk to you about unlocking your SBoMs with Yocto and some of the new features that are available in SPDX 3. So a little bit about myself. I've been working at Garmin since 2009, making electronics for boats. And we've been using Open Embedded in the Yocto project since about 2016. I'm a member of the OE Technical Steering Committee. I've also been participating in the SPDX technical team for quite some time now, and there's all the different ways you can contact me if you would like to do that. So if anyone is unfamiliar with what an SBOM is, it's basically the concept of a software bill of materials is to describe what is in the software that you're shipping to customers or using internally or otherwise distributing, um, information about that software, and then also importantly, how those different pieces of software are related to each other. There's a lot of reasons that we want SBoMs. We really want to know a lot of things about like what versions of the components are in our software, where did that software actually initially come from. A lot of people care about if they're complying with software licenses using SBoMs and things like that. It's important to know if the software has been tampered with either accidentally or on purpose. Vulnerabilities are a big thing that people care about these days also that they want to get from SBoMs. But basically the main question that SBoMs are trying to answer is, can we trace the binary deliverables or whatever it is that we're shipping back to the source code that produced it? When we're doing this with BitBake and Yocto project, I think everyone's more or less familiar with how this works, but just as a high level overview, we have some source code and some metadata, which is the recipes and some policy information. And we shove this into this magical tool called BitBake. It produces a thing we call a target image, which could be, a root file system, a kernel, anything that is the final output that we're building with BitBake. We kind of just lump under the concept of target image, at least I do for this talk. And then we put that on our widget and, profit, right? Internally, hopefully we're all a little bit familiar with how this works. So basically what ends up happening here is we have the source code for the various components that gets ingested by the recipe metadata, or ingested by BitBake based on the recipe metadata. And then it's going to spit out things based on that recipe. So in the example of the orange here, that would be the target packages. These are the things that are going to end up in your actual final target image. But we're also producing things like the native tools and the cross compilers that we're actually using to build those target packages in the first place. You can see that in blue. And even the target images themselves are produced from recipes. And all of this is sort of tied together using BitBake's very sophisticated method of hashing things, such that when things change, it will detect those changes and know automatically what needs to rebuild downstream from all the things that changed, because the hashers will change. We've been able to produce SPDX SBoMs for quite some time, and basically the concept for doing this is that when we process this recipe metadata, we've got additional tasks that spit out some SPDX for each of these recipes that we process. And then when we go to produce the target image, we take all of those individual SPDX documents and combine them somehow into some final SPDX deliverable. And this more or less accomplishes the task of tracing the deliverables back to the source code. This concept is how we did SPDX2. SPDX3 Although the final output looks a little different, is essentially the same process where we're running these extra SPDX tasks and then generating a deliverable at the end. This is the model that we had for SPDX2. I'm not going to dwell too much on this other than to kind of juxtapose it with the SPDX3 model, which is quite a bit more complicated. The diagram is in a different format because I found it easier to draw it this way, but it is more or less describing the same things. There's just a lot more detail that we can provide using SPDX3, some of which we are now, some of which we might do in the future. But it's more or less providing a similar types of information, just better. The main things that I'm going to focus on today that are new in SPDX3 are that SPDX3 now has the concept of a build, which SPDX2 just did not have. So in SPDX2, we kind of shoehorned in the concept of we built this thing. In SPDX3, that is a first-class citizen where you can say we did a build. It took in these inputs and spit out these outputs. And then in addition to that, SPDX3 also has VEX compliant CVE information. And so I'll be talking about how to adjust that for your builds. So I'm going to talk about a bunch of new features that you can enable. These are all basically extra bit-bake variables and flags that you can enable. You can do these in local conf, you can do these in recipes if you would like, or you can do these in your distro config, just kind of following the normal rules of variables. All of the ones that I'm going to talk about today are disabled by default in the Yocto config, and the primary reason for that is that they by nature are not going to make your build reproducible, which will be pretty obvious once you see what some of them are. And so just to keep things sane on the auto builder and whatnot, these are just not enabled. And most of them wouldn't be useful for the upstream project to be setting anyway. So yeah, just keep that in mind. And as I was making this presentation, I found that some of these things were broken, so I had to submit some patches to fix them. So go figure. So there are pending patches for some of these things. So just be aware of that. Sorry. All right, so the first variable that you can set is there's a new variable called include build variables. And basically, this will capture every big variable that is visible at the time that the SPDX task runs and attach it to the build element. So if you would like the value of any bit-baked variable to be reported in your SBoMs, you can do that by setting this. It's a lot of data, so do be aware. So that one's kind of interesting. This one also existed in SPDX2, but this just makes the SPDX output pretty. So it inserts new lines and spaces and things like that that people like to see. If this is not set, all of the SPDX output is a single line of JSON, which, as much fun as that is to read, can be you probably want to set this if you want to look at these manually. Yeah, so this one will record the timestamps of when things were done. Very obviously, this is not reproducible, so be very aware of that. But basically, if you want to know exactly when builds happen or when artifacts were produced, you can set this, and then those will be included in the SPDX output. Yes, I haven't published my slides because I finished them 5 minutes ago, so I will do that. SPDX3 also has the concept of nested builds. And so the way that this works is that you can say that one build was an ancestor of another build. So like these builds were like subcomponents of some parent build. And so you can set this variable to have the have bitbake spit out this hierarchy. And what it does is it basically, whenever you invoke bitbake, it creates a build element that describes that run of bitbake. And then every recipe that gets built during that run will be attached to that parent bitbake build. using this ancestor of relationship. So if you have, particularly when you're dealing with S state, if you would like to track when each recipe build was done over time from S state through different invocations of bitbake, you can do that using this flag. And the reason you'll want to do that will be more apparent in a minute. But you can see here, like we had in this example here on the right, there's two invocations of bitbake that each built a recipe, each built two recipes, and then the final image build pulls in one recipe from one bitbake build and the other two recipes outputs from another bitbake build. Realistically, that would, this is mostly helpful when you're talking about S state, so you can track that. SPDX links objects together by SPDX IDs, which are they're called URIs, which is IRIs, which is basically just a URL looking thing that is a universally unique name for an object. So all of the elements that are in SPDX have to have one of these SPDX IDs. And if you're generating an SPDX document that references an object that doesn't exist in the document, you have to import it. This is just part of the spec. And so the way that you do that is using this SPDX imports variable. So if you're say need to reference this SPDX ID in your document, which there will be use cases for that in just a minute. So if you need to reference this like spdx.mydomain/object somewhere in your document, then you need to import it using this variable. And you can also specify the URI where the document that contains that SPDX ID lives, and then the hash of that document for validation too, if you would like. Okay, so the reason that you might want to link things to your bitbake build is because you can actually record who invoked the build. So this can be useful, and you do this using this SPDX invoked by name. So you can actually say like this build was done by this person. You can also say that the build was done by a piece of software or an organization or something like that. These are all encapsulated in the concept of an SPDX agent. There's a big comment block in create SPDX 3.0.bb class that kind of describes how to construct these, but more or less there's like a base variable, which in this case is SPDX invoked by, and then there's like sub fields of that variable that tell the code to create the object or reference an import. As you can see, like that SPDX invoked by import A, that means reference the object that I imported as import A. Or you can like reference other things that other variables that are creating agents too, if you want to do that. There's also the concept of saying on whose behalf the build was done. This starts to get kind of complicated, but the basic use case here is that if you're doing builds in say like a GitHub Actions, GitHub is really the software agent that invoked the build, but it may have been invoked because of a pull request done by a user or because of a tag made by a user. And so you want to be able to encapsulate that, GitHub Actions did the build, like mechanically ran bitbake, but it was done on behalf of some other user. And so there's a way to do that also using this SPDX on behalf of variable. I won't get too far into the details of how this is set up in SPDX itself. It is a little bit tricky, but basically you can just set these variables and it will record that information. There's also the concept of the build host. So if you have a software bill of materials for the host that you're running the build on, you can tell bitbake to link that into your generated documents. And that can give you a really deep supply chain if you have that SBOM. And you do that using this SPDX build host variable. And basically that must be a key into an import. So, in this case, we say it's the host key. We add the host key to our imports variable, and then we say what the SPDX ID is for that. And that will use this has host relationship to link your builds to whatever the host SBOM is. There's also the concept of a package supplier. So this is the entity that is supplying the package that is supplying the produced packages. So if you're shipping a package to someone else as an organization, you would be the package supplier for that. It's roughly like, who do I contact for like when I have a problem, or for like maintenance, or who's supporting this. In a sense, it has a little bit different definition than that, but that's the basic idea. And so you can set this up so that you can report your usually organization as the supplier, although you could do a person here too if you wanted to. So you can set these variables to do that. And again, this is one of those agent variables that you can set a whole bunch of different properties for if you read that comment. There's also authors. So these are supposed to be the authors of the SPDX document itself. SPDX is very concerned about who produced the actual SPDX output, and that's what this is referring to. You can have multiple authors if you want to go down that route. Basically, the SPDX authors is a key of what authors need to be created, and then for each key, it's one of those agent objects again that can get created or referenced or imported or whatever, just like all the other agents listed. So as I mentioned, all of the objects that are written out into the SPDX3 document have to have this universally unique URL IRI thing. And those are generated by BitBake by combining the SPDX name prefix variable and the SPDX UUID namespace variable. So the UUID namespace is basically used to hash some stuff to create a unique for your build instance name for the elements, and then the namespace prefix is just what's put on the front of all the IRIs that are produced. There are default values for these. However, if you are distributing your documents to anyone else at all, you pretty much have to change these. Because there's a good chance that if you just use the defaults, two people could publish a document with the same IRI for an element that was produced. And two things that have the same IRI are considered to be the same thing. And so you don't want that because they need to be universally unique. So if you are distributing documents to someone else, or even if you're just archiving them for your purposes, you should almost assuredly set these variables so that you get unique IRI names for all the stuff you're producing. As I mentioned, SPDX3 has VEX compatible vulnerability information, and you can control what level is included by BitBake in the output that it produces. There are 3 levels. There's none, current, and all. So none just doesn't include any VEX information. If you don't care about that, it can save you some build time. Current, which is the default, will only include VEX information for CVEs that aren't fixed by the upstream version. So if a CVE is found, but the version of the package, the upstream version that we're pulling in of that package has already fixed it, it will not be included in the SPDX output. And all will just include everything. And all can generate a lot of data, in particular for the Linux kernel, because there are just a lot of CVEs for the Linux kernel, which is why we added this option in the first place. Current really cuts down on the number of CVEs that are reported in the actual SPDX output, which makes it run a lot faster. And also, it's the stuff you actually care about, like this CVE isn't fixed by the version of the kernel that we have, but we patched it ourselves, or it's not fixed, or we're ignoring it, or whatever. You get the basic idea. So you can mess around with that depending on what level of granularity you want. There's also an option to include the sources. So the SPDX3 output already will list all of the files that are in source URI as inputs to the build. But if you set this variable, it will actually go through the unpacked sources and list all the files that are in the unpacked sources and their hashes and scan them for licenses and then list those as inputs to the build. So this is really useful if you want to be able to say, you know, this hash, a file with this hash like has a vulnerability or something like that. Was it in my build? And if you set this variable, you can do that. It's off by default because it just generates a ton of output. And we're also actively working on some patches to make this flag a little bit more efficient. Time-wise, there's not really a lot you can do to make it generate less data per se, but it is a little bit slow right now. All right, so the question I always get is, I have a document. What do I do now? So the shorter answer is we need tools. It's pretty easy to generate SPDX3 output that's larger than the deliverable you're describing because compilers are actually really good at compressing source code. Um, and that's great. But it is a lot of data. And it's all well-structured data. It's JSON LD, so you can read it manually, but really you're going to want to use tools to deal with this stuff. So SPDX3 has made some improvements that are actually pretty good from the tooling perspective. The first one is that SPDX3 documents are RDF compliant JSON LD, which means you can actually use any off-the-shelf RDF tooling to parse them. So if you really like RDF or if you're familiar with RDF, it is a very powerful way of dealing with structured data. And so you can actually just load an SPDX3 document up into any RDF parser like Python RDFlib and deal with it that way if you'd really like to. So that gives it a huge boost on the amount of available tooling and things that you can use for this. In addition to being RDF compliant, though, it also has a very strict JSON schema. And that schema forces it to be RDF compliant, but also very much simplifies and restricts what you can do in the document so that it can be parsed by just very simple more simple JSON parsers, because RDF is a very complicated thing. You can do a lot of crazy stuff with it. The JSON schema really restricts that so that you can deal with it with just normal JSON data instead of having to use RDF. There's a tool that I wrote called Shackle to Code. And this actually takes in the RDF model, the SPDX3 RDF model, and spits out code bindings in a couple of different languages. And this is actually what we're using to generate the bindings that Yocto uses. So it can generate Python bindings, C++ bindings, and we're working on Go. But yeah. So I wrote a collection of standalone tools that I'm going to go over very quickly. I'm not going to go into too much detail on them. I did write all of these. Partly I wrote these out of necessity because I needed to do things with SPDX3 documents and there weren't any tools that existed. But partly also because I wanted to demonstrate that these simple standalone tools are actually possible. A lot of SBOM tooling you see these days is big websites and front ends and databases and things like that. And I just don't want to do that just to look at a document and do stuff with a document that I have. So I wanted to like prove to people that yes, you can write these simple standalone tools, and they do work. So the first one I have is this tool called SPDX3 Query. You install this with pip. It basically is a SPDX interactive browser. So it lets you navigate around a document, do queries in documents and find things, and just generally kind of see what's going on. It's like a guided tour through your document, more or less. So you can check that out if you want. There's another one I wrote called SPDX3 Merge. Again, you can install this with pip. And basically, it just merges multiple documents together. And if you've ever listened to me ever give a talk about SPDX2, one of my biggest complaints was that you can't merge documents easily. It was just really hard. It is much easier with SPDX3. There's a relatively simple algorithm you can use to merge documents together. Yocto actually implements this algorithm. So one of the nice things about the SPDX3 output with Yocto is that it is one one JSON LD document that it describes the entire target image instead of what we had for SPDX2, which was a tarball of SPDX2 documents because it was really hard to merge them. So I'm really excited about this. And basically this SPDX3 merge is a standalone implementation of the same algorithm used by Yocto. This is a validation tool. Again, you can install this with pip. This will validate both the JSON schema of a document and the RDF of a document. So in broad terms, you can think of the schema as the structure of the document and the RDF as the semantics. There's some overlap. It's not entirely like divided like that, but it's basically how it works. This tool does require an internet connection because it's going to go download the schema for your version of SPDX and the RDF stuff. And it is very slow. And the reason it's slow is because Python 3 JSON schema is very slow. I don't know why, it just is. There are actually faster JSON schema checkers out there, but none in Python. And since this tool's in Python, I just use that. So just be aware, it takes a while to validate a document with this. I will point out, if you want to try this, SPDX 3.0.1 does have a slight bug in the current RDF documents that are published for it that prevents the validation from actually passing. They're hopefully going to fix this with next week. They'll just replace the documents online, and this tool will just find them and then it will pass. So that is a little bit of an unfortunate thing, but they are working on fixing it. All right, that was really fast. Any questions? Okay. Yes, I will upload the slides after this. I'm notoriously bad at working on my slides till right before my talk. And yeah, we don't have plans on supporting Cyclone DX in OE Core. There are external layers I've seen that do it, but we're only going to do SPDX in Core. Just yeah. SPDX3 was just added in StyHead. There's no plans to backport it. It's pretty invasive. Yeah, I don't think it won't be backported. Yeah, the Yocto layers and sources, I would like to add that to the SPDX stuff. That's really tricky to capture. It's surprisingly difficult to capture that. Not impossible, but I think it could be done. Someone would need to sit down and really think about the best way to do that, but that would be good. Yeah, so SPDX3 query, you could integrate it into DevTool. I don't know what that would gain you over having the standalone tool, unless there was a specific use case you were thinking of. But again, if you wanted SPDX support in DevTool, like you can just use the bindings. Like you can either generate new bindings with shackle to code, or those bindings already exist in Yocto as generated code. So you could pull that in and basically manipulate an SPDX document in any Python tool pretty easily. SPDX Lite. SPDX Lite isn't a thing in SPDX 3. They're really they simultaneously made SPDX more expansive and also kind of streamlined some of the things. So Lite it's not like a separate format. It's basically just a restriction of the existing stuff and additional requirements. So it's not a separate format or thing that exists anymore. It's basically just like yeah, it's just a restriction of the existing SPDX stuff. Yeah, they did put a lot of work into making SPDX3 a lot more advanced. It's a lot better. It's got a lot of nice stuff. As far as like running a vulnerability assessment from SPDX3 using the SBOM only, You can do a limited amount of that with SPDX, with that SPDX query tool. It's got some things. I wrote some logic in there to do the thing that I was talking about, where you can actually say like, I've got this file with the SHA-1, show me all the downstream stuff that affects that. I'm not aware of any standalone tooling outside of that. But again, I like what I would like to demonstrate is like if you have a tool that you would like to write to do that kind of thing, I think it's a lot easier with SPDX3 with the generated bindings and all of that stuff. Um, so I think those kinds of tools should be a lot easier for people to write. Yeah, there's not an SPDX4 planned. Does setting SPDX archive package add compressed archives of the files installed into the targets? R depends only. I don't remember. Um, yeah, SPDX archive packaged is designed to make a tarball of the. It's very similar to the archiver. It's yeah. You can use it, but it's not the greatest thing.